So welcome back to our math sessions, and we are still continuing with our question for calculus. So we are now on question 8. This was our question 8. So if you look at our question 8, it basically had h of x, which is given as negative x cubed plus px squared plus qx plus r, as well as that this is the graph of h. This is our h of x is represented graphically, as you can see that our h of x, it crosses at c and at d. At c is 2, you can see here. At d is 5. So this is information which is given. Our first question is here, 8.1. Show that p is 9, q is negative 24, and r is 20. So we are supposed to show that these are the values of p, q, and r. But before we can show that these are the values, let's talk about what is the concept behind, before we can just make a calculation and show each other how to get it. But to understand cubic or a calculus topic is that we should understand that this is a cubic function. If you are already given x values, then it means that you have to put them in an algebraic format as the factors of h of x. Then you have to FOIL them and expand them. Let's start that. So, which means our h of x, let's forget about this one given, but what we should understand is that since a here is negative, that makes our a to be negative, and you are going to open a square bracket like this. You put your factors, x is equal to 2 and x is equal to 5. But understand that this one, it's a double factor. Why? Because it's both a factor and a turning point. So when you put it on the x values or on the x-intercepts, you must understand it's going to be x minus 2. You change the sign here. Again, another x minus 2. Then this one will be x minus 5. So this is the starting point. Understanding you have a double intercept here, you put it double, you have another intercept here. Now what is needed now is the ability to expand this. Let's expand this. We are going to keep our negative outside. Then we have this one, which is x squared in a bracket minus 4x minus positive 4. Then we still multiply with x minus 5. Again, let's FOIL these two. We are going to have negative outside. Then x times this one, this is x cubed, x times this one, minus 4x squared. Then we are going to have x with this one, plus 4x. When we are done multiplying with this one, let's use this one to multiply everything like we did on the x. Minus 5 times x squared, this is minus 5x squared. Minus 5 times this one, positive 20x. Then minus 5 times this one, this is going to be negative 20. So you see, after this one, let's collect like terms within the square bracket. Let's collect like terms equals to, we keep our negative, our x cubed is here, minus 4x squared, minus 5, it gives you minus 9x squared. Then 4 plus 20, it gives you plus 24x, negative 20 at the end of the day. So this is what we have in the square bracket. Let's bring in the negative outside to change every sign inside, and we are basically going to have something that looks like this. Negative goes inside, it becomes negative x cubed. Negative goes inside, it becomes positive 9x squared. Negative goes inside, becomes negative 24x. And finally, this becomes positive 20. So a question for 3 marks, as you can see here, that it now looks exactly like this, with our p being 9, our q being negative 24, our r being 20. So this is how you are supposed to do. You are supposed to solve this one, collecting your x-intercepts and FOIL them until the end, until you get the answer. So let's move on to the next question. After this one, there was a typical question after this. We're still using the same information. We now have our values. This is our h of x. Our h of x has been found. So we move on to the next question, which was typically question 8.2. So our 8.2 was very simple question for 1 mark. It was supposed to be that this is the turning point, which is B. This is our O, the origin. So the question was, you are to determine length of OB for a mark. Length of OB. How long is our OB? From O to B. So here's a question about finding y-intercept, but they put it in a different format. So you're literally going to find y-intercept. Let's find y-intercept. How do we find y-intercept? Here is our h of x, which is negative x cubed. Then our p, that is plus 9x squared. Our q, minus 24x. Our r is plus 20. So having this one, we know that how do you find y-intercept? You find y-intercept by making x to be equals to 0. If this becomes 0, 0, 0, which means what's left is the last number without an x, which is 20. So basically, coordinates of B are going to be 0 is to 20. So to get OB, length of OB, we can now say that B is 20 units. A typical question for 1 mark. It was a 1 mark question. So let's move on to the next question, which is question 8.3. So we are still on the same information, question 8.3. So let's move on to question 8.3. What was the question on 8.3? It was also a typical question on how we can use our procedures for solving calculus, like the turning points, stationary points, points of inflection, equation of tangents, etc., etc. The next question was point of inflection. We will find point of inflection. How do we find point of inflection? Point of inflection is very simple. Find the first derivative, so find the second derivative and solve it by making it equal to 0. Let's do that here. We have our h of x, which is equal to negative x cubed, then plus 9x squared, then minus 24x, and then plus 20. So let us find the first derivative. The first derivative, bring down 3, negative 3x squared. Bring down 2 times 9 becomes 18x. Then you're left with 24. Again, let's find the second derivative. Our second derivative, bring down 2, is going to be minus 6x plus 18. So basically, we have found the second derivative. But on a second derivative, that's where you get what's called point of inflection. So let's explain what's point of inflection and where do you find it. If you look at our graph, the graph is decreasing towards C. It's going to turn here and it's going to increase towards the other turning point. So the region between the first turning point and the second turning point, this region, that's where you find what's called the point of inflection. Somewhere here, that's where we have our point of inflection. So which is between 2 and this turning point. So let us solve this one to find the point of inflection. So I said this one must be made to be equals to 0. Let's do that. Negative 6x. If 18 goes over there, it becomes negative 18. So how do we solve this? Divide both sides by negative 6. So we have something that looks like this. Negative 6x divided by negative 6 is equal to negative 18 divided by negative 6. If you cancel out here, you'll be left with x is equal to 3. So we found that somewhere here at x is equal to 3, that's where we have what's called point of inflection. So point of inflection is found between the first turning point and the next turning point. So our x is equal to 3 is our point of inflection. So after the point of inflection, let's move on to the next question, which is question 8.4. So let's wrap this one information here. So the next question is that The next question talks about what's called equation of a tangent. So the next question is about equation, what's called equation of tangent. Now, equation of tangent at which point? Because a tangent is a line which touches the graph once, but it touches at which point? In this case, it was not given, but the only information given is that we need equation of tangent with what is called inclination at 96,34 degrees. So 96,34 degrees, but the information provided also is that it is between B and C. So if we were to draw that line between B and C, it's a line that I'm going to put in a dotted format like this. Okay, so this is our tangent. So having this tangent, they are saying that its inclination, the angle that it makes an angle. The angle it makes, they say it's 96,34 degrees. So now, what we need to know is that we are going to have something like this. The first part, inclination here is a formula. What is the formula for inclination? The formula for inclination is that m is equal to tan theta. That's the formula for inclination here. Then we also need to understand that equation of a tangent has a formula, y is equal to mx plus c. That's the equation of a tangent. And we know m represents what? Gradient. If m represents gradient, how do we find the gradient? Gradient is the derivative. So we have two things here. The inclination m is equal to tan theta. The equation for the formula or the format for equation of a tangent, which is m is equal to, it's a derivative. That is our dy over dx. Let us find the derivative. Our m is equal to be the derivative, which is negative 3x squared, and then our p was 9. Our p was 9. Let's write here. That was 9. Our q, that was minus 24. So we are going to have plus 9 times 2. We have 18x, and then we have minus 24. That's basically our derivative. So we are saying that this derivative, which is m, let's come to the side of inclination. M is equal to tan of theta, which is 96,34 degrees. Now, if you punch this on a calculator, you find that your m is going to be negative 9,0002. So this is your m, this is your m. That means you are to combine this one and this one to be one. So we are going to create space. Now we understand what happened here. Let's start from here. Let's wrap this space and create space for ourselves. And we continue now with our question on a clean sheet. We are going to have this one. Our m is basically equals to negative 9. Our m is this one. Let's join this m and this m and solve for x. Negative 3x squared plus 18x minus 24 is equal to negative 9. Let's bring negative 9 over here. Minus 3x squared plus 18x. 9 comes over here. Minus 24 plus 9 becomes 15 equals to 0. Let's factor out minus 3x minus x is going to be minus 6x, and then x is going to be this is supposed to be negative. When this one comes over as negative, it changes to become positive 5 equals to 0. All right, let's find x values. Minus 3. So we are going to have our x values being equals to x factors of 5 and 1 minus 5 x minus 1. So finally we are going to have x being equals to x here being equals to 1 or 5. but we have to reject 1. X cannot be 5, X has to be equal to 1. For what reason? We saw that when we demonstrated that the first x-intercept was 2. So it's between 0 and 2. So we have to adopt this one and reject 5. So therefore, adopting this one and rejecting this one, it helps us to find what's called the y value. Let's find y value. So our x is equal to 1. Our x is equal to 1. We reject x is not equal to 5. We reject this one. Let's substitute this one into the original. What was our original? Our original was h of x being equals to negative x squared. Negative x squared. We have plus 9x squared. X cubed here, sorry. 9x squared minus 24x, and then plus 20. Plus 20. So this was the h of x. So let's substitute x here. So y is equal to negative 1 cubed plus 9, 1 squared minus 24, 1, and then plus 20. If you punch calculator properly, you find that your y is equal to 4. So y is 4, x is 1, our m is negative 9. So let's combine all this information into this. So y is equal to mx plus c. So our y value is 4. Our m is negative 9. Our x is 1 plus c. Let's find c. Take this one over here. It means 13 is equal to c. So at the end of the day, y is equals to our m, which is negative 9. Negative 9x plus 13. This is how we determine the equation of the tangent. So, our equation of a tangent. So, all this information from here to there, to here, until there, until the final answer. So, thank you so much for watching our videos, and keep on subscribing. Keep on pressing all the follow and notification buttons until we meet again next time on the next question. Thank you so much.